So hello everyone. So today we have the mock interview. So today we have the Ravi. Yeah, Ravi, we can start with your introduction once. You can
Yes.
give the brief introduction.
Uh, Good evening, everyone. I am Ravi Vinay. I basically belong to Andhra Pradesh. I am from Andhra Pradesh, and I have done my BTech bachelor's in Electronics and Communication Engineering branch in BML Munjal University. Later, I have worked as a quality analyst in Smart Energy Water company named Smart Energy Water for around one year. Later, I have written GATE in 2023, and I have got seat in IIT Kharagpur under in the branch of Instrumentation and Integrated Electronics. So currently, I am pursuing my master's degree in Instrumentation and Integrated Electronics branch of IIT Kharagpur.
Okay. Okay. First question is what is the difference between latch up and flip flop? Sorry, latch and flip flop.
So basically, latch is a level sensitive sequential element, and whereas flip flop is a edge triggered thing. And latch is less prone to, flip flop will be, as if flip flop is edge triggered, it will be less sensitive to glitches, and whereas latch will be more prone to glitches, like hazards like static hazard and dynamic hazard.
Mm.
And yes.
Okay. Kishore, you want to answer it?
Yes, sir.
Yeah, you can answer it.
Sir, generally, latches are like level sensitive devices. Like whenever
Turn on the camera once. Pहले turn on the camera.
oh, okay, sorry.
Yeah.
Yes, sir. Am I visible?
Yeah.
Uh, yes, sir. Latches are basically like level sensitive devices. Like they are sensitive whenever the clock level is high or low, depending on whether it is a positive or negative latch. Whereas flip flops are like edge sensitive devices. They will be triggered at the 0 to 1 or 1 to 0 transitions. Yes.
Mhm.
And coming to like latches are like more sensitive to glitches, whereas flip-flops are not. That is one of the difference between them.
Mhm.
And yes,
Okay, tell me the difference between sequential and combinational circuits. Ravi first. First, Ravi.
Uh, the combinational circuit output will be dependent only based on the present input that is being applied. Whereas in sequential element, the current output will be based on the present input and also the previous output. So it basically sequential element consists of a memory, whereas this combinational circuit does not has any memory element. Yes, sir.
Okay, only two. Okay. Oh yeah. Kishore, you can continue. You can add more points.
yes, sir. Combinational logic is like normally using AND gates and thing. They do not have any memory elements such as flip-flops. Like whenever we go into sequential circuits, clock thing comes into picture. Like the contents can be changed only when at the active edges of the clock. Whereas in case of a combinational circuit, the circuit is continuously driven by the inputs. Whenever there is any change in the input, the output will be reflected irrespective of the thing. It is yes.
Give the example also. Example. At least 5 points
Combinational
should be there, right? At least 5 points should be there.
yes, sir. Combinational logic can include these things such as half adders, full adders, decoders, and muxes. Whereas sequential logics can include registers, counters, all the memory things. Yes, sir.
Okay. Okay, fine. Uh, what are universal gates and example of that?
Universal gates are like any gate which can implement all basic gates. Like uh, suppose if any there are some basic gates like and, nor, and, or, and not. So if any gate is able to perform all these operations with only by using only that particular gate, then we call it as a universal gate. The examples of universal gate might be NAND, NOR, and this implication and inhibition
Yeah.
gate.
Kishore, you want to tell?
Yes,
Correct
sir.
it?
Universal gate is things like by using these basic blocks, like any of the logic can be implemented. Normally, NAND,
Any
NOR,
logic, any logic.
any logic can be implemented using this. And normally NAND, NOR, and as well as MUX can also come under universal gates. Yes, sir.
Yeah. Can you explain how the mux is universal circuits?
Because using MUX, we can implement a NAND and NOR, which themselves are universal gates. So using MUX, we can implement any
Okay.
logic. Therefore,
Also, you should know the diagram, right? Circuit diagram, how to implement different gates.
yes.
Yeah. Application of mux. Application of mux. Or a way you can tell.
I mean, in mux we can use like whenever we are having a single output line and we driving multiple inputs with the, I mean, suppose if I want to select only one particular input uh, to drive the output, then we can, in that specific cases, we can use mux. Uh, yes.
Yeah. Kishore, you want to tell?
Yes, sir. MUX, as we know, is like a select logic. Whenever suppose there are multiple channels and each of the channel is having some identification, such as some control logic. Based on the control logic, we can select the particular channel when depending on our con- requirement. So for that, MUX can be used.
That is one application. Other application.
And MUX can be used to implement various combinational logics as well as half adders and full adders can be implemented using MUX. Therefore, so it can form a part. It can form part of various other devices in
ADC,
uh,
DAC circuit conversion.
gates.
Right.
Yes, and even in
Code
case of
conversion.
ALUs, ALUs also it
Even
can be a part.
in communication system we use mux, right?
In case of time
Okay.
division and these multiplexing techniques, we can use.
Yeah, just check it once. Uh, next application is demux. Application of demux.
Uh, in the similar way as Marx, if here in the, I mean, in somewhat different way. I mean, if we are having single output line and if we want to pass it through I mean, a particular output line, then we can use demultiplexer, and it can also be used for code. I mean, code generate code conversions. Like if I'm giving I mean, single bit, I can, I mean, one hot converter, it can be used as one hot converter. Only as only one output line will be active at a particular time. I mean, based on the select line.
Here to parallel converter, you are saying, right?
Yes, yes.
Yeah. You want to continue, Kishore?
Yes, sir. Demux is like it is also a combination implemented using combinational logic, but coming to the use, I think there can be some equivalence between demux and a decoder, like
Data
the
distribution.
data distribution. So, and we know decoder can be when combined with some OR gate can be used to implement any universal logic. So same can be done with demux as well if we consider
Okay.
it as like a decoder. Yes.
Okay. I will ask the question. Uh, Tell me whether it is combination or sequential circuit. Which is faster, combination or sequential?
Combinational.
Combinational.
Combination. Okay, fine. Which is easier to implement? Easier to implement.
Combinational.
Combinational.
Why?
I mean, it does not require any memory elements and all. So direct with the
That's
direct
hard.
Yeah,
transition level with
Yeah. Clock is not required in which?
and no timing requirements, nothing since clock is not there here. Nothing
In
becomes
which clock is not required? Clock is required in which? Clock
sequential circuits.
sequential
Yes.
circuit. Memory is required in which?
That
sequential.
Memory is required in which circuit?
sequential
Sequential.
circuit.
Example. Uh, Shift register is example of.
Sequential
Sequential circuit.
circuit.
Counter is example of.
Sequential circuit.
Okay. Decoder is example of.
Combinational
Combinational circuit.
circuit.
Okay. Tell me about setup time and hold time.
Setup time is nothing but it is the minimum amount of time before which the data must be stable up before, I mean, before active edge of clock comes, the data must be stable and ready. That amount of time is not, I mean, is called setup time. It is the minimum time before which the data must remain stable before applying clock.
You want to make the diagram also? You want to show me using
Yes.
diagram? Yeah, Kishore, you want to, yeah, tell,
Yes,
continue.
sir. Setup time and these hold times are coming from the internal structure of the flip-flops. Whenever we want to store any data into the flip-flop, it is not that just at the active edge of the clock the data cannot come. So there will be some window between which the data has to come or the data has to change. So setup time is like the minimum amount of the time before the active edge of the clock that the data has to be stable so that for it can be captured correctly. And hold is like minimum amount of the time the data should change so that whatever previous data that is there that won't be corrupted by the new data. Yes.
Okay, okay. If we not meeting setup time and hold time, what will be the problem?
But
If
we may enter into the metastable state so that we can't say the where the flip-flop finally output finally settles, and it depends on the polarity of the noise, and it when it finally settles also depends upon the drive strength of the flip-flop and many other things. So entire design can be affected because of this.
Tell me two ways to resolve the setup and hold time violations.
to reduce to remove setup time violation, one thing we can do is reduce the data path delay by using low VT cells, or by inserting buffers in order to reduce the clock slew, so that clock to queue delay will be reduced. And one more thing, we can also modify clock path delay by reducing by increasing clock path delay to capture flip flop. But in general, it is avoided until or unless we are able to, until or unless if we are able to achieve setup time, we are able to remove setup time violation through combinational delay. We should avoid using I mean, clock path delay. We should avoid touching that clock path delay because it may violate some other circuits violation. So either we can use low VT cells, or we can place a buffer. By placing buffers, we can reduce the delay. So the slew will decrease, and clock this flip flop slew will also decrease, and this will decrease. And in the similar way, yes, yes.
Okay, Kishore, you want to tell?
Yes, sir.
Meanwhile, you can write the equation. Ravi, you can write the equation of setup time and hold time violations. Meanwhile,
Okay.
fine. I will check it. Yeah.
Yes, sir.
Kishore.
Whenever there is setup violation, first of all, we can try to modify the data path. Like whatever cells that are there in the data path, those can be upsized so that delay of the respective cells in that combinational logic can reduce. And another thing that we can use is we can use another flip-flop with a lesser setup time constraint, and we can also go with low VT cells so that the delay of each thing can be reduced. And if none of these is able to meet the setup constraints, then we can try to modify the clock path. But that will be the last option. And even after that, like after the chip is fabricated, maybe if there is a setup violation, then there is no other option other than reducing the operating frequency at which it is designated to operate. Yes.
Okay. And what about hold time?
And coming to the whole time, what we can do is we can use the downside cells in the data part so that their respective delay will be increased. And at the same time, we can try to reduce the clock path delay. That is also like the last option because it can affect other timing violations. And try to use high voltage cells in the data path. And another option is like using a flip-flop with a lesser hold time constraint. So if yes, and
Okay.
yes,
Setup time and hold time can be negative also.
setup can't be negative, but whereas a hold can be negative. So
Okay. Okay. Are you sure? Okay, fine. In what
yes,
condition it will be negative?
uh, it will be negative like if there are in the internal structure of the flip-flop there are two cells at the beginning, that is an inverter as well as a transmission gate, and if the delay of the transmission gate is much higher than that of this inverter, then we can say like the whole time can be negative because yes.
Hmm. Okay, Ravi, you want to tell setup time and hold time can be negative?
Yes, sir. Setup time can be negative as far as you know because it is a gate. It is nothing but some combinational delay, and whereas hold time can be negative because if we internally the flip flop is implemented using some transmission gates. So in the I mean when the so during the switching time this whole time can be negative. But
Okay. Okay, fine, fine, fine. Yeah. So Kishore, you are right, right? Setup time can't be negative practically, but
Yes,
yeah, practically it is not possible. Yeah.
yes.
Okay, show me the diagram you have. Right.
setup
हम्म,
time.
ठीक है ऑलमोस्ट एक बार क्रॉस चेक कर लेना बस है ना अपने आप से खुद से चेक कर लेना
Yes, sir.
ठीक है फाइन सीडीसी के बारे में पढ़ा है सीडीसी
Yes, sir.
Yes.
टेल मी अबाउट सीडीसी रवि रवि फर्स्ट या
A clock domain crossing is nothing but suppose if there are two devices which wants to send. I mean, suppose if a higher clock suppose if I want to send data as an example of FIFO, if I transmitter is transmitting the data at higher rate and the reading device is not able to read that data with that much clock. I mean, if the writing clock is greater than reading clock, then we need some intermediate device. And if I want to transmit data from this domain to the that higher clock domain to lower speed clock domain, then this is nothing but a clock domain crossing. And in order to do that conversion, we generally use these two flop synchronizers which converts this data without any metastability issue.
ओके किशोर या
There,
टोटल
Yes, sir. Suppose if we consider any chip, there can be multiple modules which can be operating at different clocks. Uh, so whenever one of the module and other module want to exchange data, so it can be transmitting its data at one clock, which need to be received at another clock domain. In such cases, to not lose the data, or we need CDC techniques in order to efficiently transmit the data between those two clock domains, which are operating at different clock rates. So, and among these, there can be many things can be coming, such as two flop synchronizers and toggle synchronizers, etc., which which needed to be used for clock domain crossing.
you want to make the diagram also
Yes,
can you make the diagram
for
Ravi you
two
can
flop
also make
synchronizers.
you make you know the diagram also like a diagram of this cdc
Two
and
flop
all
sync. Ah, yes, sir. Yes.
so two clock yeah you can make and also there's asynchronous FIFO. So why we use asynchronous FIFO? Ravi,
so yes,
yeah, you can tell.
in general, suppose if I have if CPU is there and I mean suppose memory is there. CPU operates at a very high frequency and memory operates in some lower frequency. And so if a CPU wants some data, if wants to send some data to memory, then as the clock frequency is there is a difference of clock frequency, then we need some intermediate memory which has to store the data um, uh, in first out manner, so such that the memory will be able to receive all the data that CPU wants to send. Suppose so in this way, so as there is a write clock frequency and read clock difference, so FIFO can be placed in between in order to this asynchronous FIFO can be placed in between to capture the remained data that which
Okay.
read module cannot be able to handle.
Okay. Okay. So how we calculate the FIFO depth? So like the FIFO depth calculation?
Yes, yes, sir.
Okay. Yeah, you can write the formula on the. You can
Yes.
write the formula, general formula you can write.
Oh.
Yeah, Kishore, it is done.
Yes.
Okay. Okay.
Sir, are you able to see
This is for what? What is this?
for clock domain processing? Yes, sir.
Okay. Okay. I
Uh,
was expecting that circuit diagram.
for a
No
two
problem.
clock synchronizer?
Yeah. No problem.
Okay.
You can
Oh,
make it if it is fine.
okay.
Otherwise,
Okay.
we will go to the next problem.
Yes.
So, what is the difference between synchronous and asynchronous FIFO?
For in case of like synchronous FIFO, both the blocks are operating at same clock. Whereas in case of asynchronous FIFO, the read clock is at different frequency and write clock is at different frequency. When coming to like asynchronous FIFO, both read clock and since both read clock and write clock are not synchronized, so whenever any operation occurs, suppose read or write, first of all, it has to be serviced. So, uh, whereas in case of synchronous FIFO, uh, at only some particular clock edges, anything will happen. So that in during remaining times, the FIFO there can be another work going on. Whereas in case of this asynchronous FIFO, the read or write operation can come at any time, so that it needs to be serviced. So I think mm, synchronous FIFO tends to be somewhat faster than asynchronous FIFO. Yes, sir. So I
Okay.
think that is one of the main difference.
Okay. And which counter we are using in asynchronous FIFO?
Which counter we are using in
Yeah.
asynchronous?
Gray counter, sir.
Gray
Yeah, gray
counter.
counter. So why we are
No.
using gray counter, like
I mean,
binary?
as CDC is there, I mean, clock domain crossing is happening in between the two modules. So if we use gray counter, then only there will be one bit change in the count value. So even though, but if we use binary counter, then multiple bits can be changed. So due to which, if metastability occurs, then there is a possibility of a change of, I mean, loss of, I mean, lots of data. So if we use only gray code, then the possibility of variation with the ideal is less.
Okay, fine. Yeah, Kishore, you want to add something?
Yes, sir. The main reason for using gray counters is since gray code is always having one bit variation between any two successive codes. So there is a less chance of metastability by employing gray codes in this synchronous FIFO. So I think we can avoid false full and false empty conditions, which are quite important. If we use binary codes, there is a high chance of a false full condition.
Okay, okay.
Yes, sir.
So you
Or are you able to see, sir, for two flop synchronization?
this is a waveform. This is a waveform.
No, sir.
Okay, yeah,
Yes, sir.
yeah. This is fine. Okay, you can
Yes,
cross check it also.
yes, sir.
Uh,
And
yeah.
depth calculation.
Depth calculation. Yeah, this is almost fine, but you can cross check also, right? You can cross check yourself also, right?
Yes.
This is almost fine. Right? It seems fine. My next question is, yeah, Ravi, tell me the synchronous and asynchronous FIFO difference.
I mean, if the write clock frequency and read clock frequency is same, then we can use then the, I mean, the memory which we can use is, I mean, we can then it is called synchronous FIFO. And if write clock frequency and read clock frequency are different, then it is termed as a asynchronous FIFO.
Okay. Okay. Tell me the application of FIFO. Tell me the 2, 3 applications of FIFO.
Uh, FIFO can be used as a temporary. FIFO is nothing but a memory. So in between communication between CPU and memory devices, we can use this FIFO. And also if some IO, if CPU and IO devices, in between CPU and IO devices, if CPU wants some data to IO devices in between intermediate stages, also we can use FIFO. Yes.
Okay. Yeah, Kishore, you want to add something?
Yes, sir. As we as said, like FIFO can be used for a temporary storage element since when they are operating at different clock rates. So in order to store the data, it can be used. And I think in FIFO, since we are able to read and write, they can be used to implement RAM, I guess, because in RAM we can do both read and write as well.
Okay. Okay, fine. Just add a more application. You can cross-check it out.
Yes.
Difference between asynchronous counter and synchronous counter.
If
Synchronous and synchronous counter.
in synchronous counter, all the flip flops, we will get the clock from the same clock source. Whereas in asynchronous counter, the output of the first stage will be driving as the clock for the next flip flop. In this way, this is different. And in using asynchronous counter, we can only count, in either more up counter, or we can either do up conversion or down conversion. Whereas in synchronous counter, we can count any random sequence that is possible.
Okay. You want to add something, Kishore?
Yes, sir. Asynchronous counters, as you said, like there won't be a common clock for all the flip-flops, whereas in synchronous counter there will be common clock. And synchronous counters can be used to implement any type of count that we want, not like a conventional ripple counter, as which is done using asynchronous counters. And I think design of somewhat synchronous counters is somewhat difficult because there needs to be some COM logic coming in between, depending on the type of the count. Whereas asynchronous counter somewhat can be easily designed.
Okay. So which is more faster?
Asynchronous counter.
Asynchronous.
Asynchronous. Asynchronous faster or synchronous?
I think synchronous is faster because in asynchronous.
Synchronous is faster. Yeah. Okay, tell me the some applications of flip-flop.
Sir,
Application of flip-flop.
flip flops can be used in various states. Like in counters, it can be used in shift
The
registers. It
thing
can
needs
be
to propagate.
shift registers. Also, it can be used. Uh,
As a delay, we can use
yes,
as a
and to
data transfer, frequency divider, right?
as a memory, it can be used
Memory
in
also.
industry. Yes,
Okay, okay.
yes.
What is the application of buffer? Buffer.
Uh, when, to delay the any sequence, we generally use buffer. And to, in STA, in buffer can be used to improve the slew rate. Such by increasing the drive strength of the buffer, we can improve the slew rate of this clock
Remove
signals.
the crosstalk basically.
Yes, yes, yes.
Okay. Mm,
Yes, sir. Am I audible?
yeah. Kishore, continue.
Yes, sir. Buffers, as Ken said, like whenever there is more amount of delay in some path, in order to reduce the delay, buffers can be used if they are properly sized, and
Mm,
from a and they can be also used for impedance matching.
mm.
Yes.
Okay, okay. Tell me the pipelining concept in computer architecture.
Pipelining is nothing but, suppose if we want to perform multiple, instead of performing a single, to perform a single operation, there will be but many micro operations that has to be performed. So if we divide these micro operations in some particular stages, so we will be able to achieve, for the first input, it may take the n number of stages to deliver the output, but for the remaining output, it will, as it will run parallel, run sequentially one by one after the other. For the remaining clock, for the remaining inputs, if only with one clock cycle delay, we will get all the outputs.
Okay. Okay. Just make the diagram and write the formula also. Oh yeah. Kishore, you want to you can continue.
Yes, sir. The pipelining concept is like whenever there is a single task that can be somewhat partitioned into multiple tasks, and there need to be a condition that whatever partitions that are there, those can operate simultaneously, simultaneously. So that is the concept of pipelining, and one of the main important things is it is used when to increase the throughput or to reduce the latency in executing any instruction. So that is pipelining.
So what is throughput according to you?
Throughput
What is
means like
throughput?
per second, like how many instructions that a pipeline is able to complete that execute. That is the throughput. Yes.
Okay. Okay. Or you can just make the diagram and all. You can make the
Yes.
diagram. And tell me that there are different type of stages in pipelining. Can you name them?
Sir, different stages in pipeline.
Stages in pipelining. Yeah.
You mean instruction fetch,
5
instruction,
stages. Execute. decode.
instruction fetch,
You mean
instruction
okay.
decode, execution, execution, write back is what I can.
Yeah. Fetch,
In-
decode,
instruction
execute,
fetch,
decode,
decode,
access, memory access,
or
and write back. 5 stages. Done.
Yes. Pipeline.
ठीक है. Okay, fine, ठीक है. Correct है. Yeah, tell me the difference between RISC and SICS. RISC, CISC. Difference.
RISC is nothing but reduced instruction set architecture, whereas CISC is complex instruction set architecture. In reduced instruction set architecture, less number of addressing modes and instruction set architecture will be there, and it will be less complex. Whereas in CISC architecture, it will be there will be more number of addressing modes and more number of instruction set. It has higher instruction set architecture, so it is in general it has some complex circuitry.
Okay. Okay. Which have the lesser register? Which have the lesser
Reduced instruction set RISC.
RISC have the lesser register? No,
Yes.
6.
this have.
More addressing mode have, which have the more addressing mode?
Complex CISC.
6. Yeah. Pipelining is difficult in which is pipelining is
CISC.
This
okay. Which have the more emphasis on hardware and software, which is more hardware and software, which is hardware and which is software emphasis. 6 is software related, and sorry, RISC is software emphasis on software, and other 6 is related to the hardware, right? Okay. Okay. Yeah. Kishore, show me the diagram.
you are able to see.
दिख रहा है.
Yes, sir. I have written that formula K plus N minus 1 into T.
Yeah. Okay. Okay.
Yes.
You know the derivation also, like 4, 5
Yes,
lines.
sir.
Yes.
You know about DMA? DMA पता है?
Yes, sir.
Tell me about the DMA.
If memory, if we have to, if IO devices want to communicate directly with memory, in general, it used to travel through CPU, but this DMA is used as a controller in between IO device and memory to perform IO related operations. So it can take control of the bus from CPU, and it will hold the bus for certain time such that the IO devices can communicate with memory directly. Yes.
Just write the diagram, make the diagram. Kishore, you continue.
Yes, sir. DMA stands for like direct memory access. Normally, whenever any IO devices want to access the memory, it happens through CPU. But whereas in order to improve the memory access, like to reduce the memory access time, we can use DMA. Normally, it uses a DMA controller. So whenever it wants any IO device wants to exchange any data, so it can send some acknowledgement, and based on that, the DMA controller can request for the control of system buses for some time, so that it will be so that data will be exchanged between these IO devices and memory directly. During that time, normally CPU will be doing some other operations like which don't require the system bus. But however, most of the time CPU will be ideal, so which is somewhat loss. So then it also needs some sort of mechanism so that again CPU can take back the control of the bus, so that entire efficiency of the entire system won't reduce. Yes.
So what is the mechanism? Tell me about the mechanism.
There can be several mechanisms. Like first of all, one thing can be like burst mode, where first of all the IO devices entirely exchange a burst of data between the memory. Then again, CPU takes back the control. And another type is like there is a cycle stealing mode. Normally, when any IO device want to exchange data, it takes a lot of time, first of all, in preparing the data so that it can be exchanged. So immediately the system bus control won't go to the IO device. During that time, the control will remain with the CPU so that it will perform some operations. When the data is ready, at that time only the system bus control goes to this DMA controller. Whereas there can be another mode like interleaving mode, like when CPU is not requiring the system bus, at that particular time only the system bus control goes to the this DMA controller. But the problem with this is the data transfer between the IO device and the memory will be very slow, because most of the time the DMA control won't be getting the access for the system. Yes.
Yeah. Ravi just shows me the diagram. Okay. Okay, this is almost fine. You can cross check it also, fine.
Yes, sir.
Okay. So you know about the cache memory, right?
Yes.
Yeah, tell me about the cache memory.
Cache memory in general use the concept of locality of reference. Suppose if a memory if suppose a CPU is accessing some particular location, it there is based on the locality of reference concept, it will definitely going to access the same location again, or the nearby locations very soon. So in general we use so based on this concept, so we place this whole we take this whole block of this content, and we place that in some faster memory, so, which is known as cache memory, which has faster access time and less delay. So instead of going to memory which is slower devices, we can the CPU can access data directly from the cache memory itself.
Okay. Okay. Kishore, you can add something.
Yes, sir. Normally, cache memory is generally used to improve the is generally used to reduce the average instruction execution time. So that is the main purpose of cache memory. So the basic concept regarding cache memory is whatever data that can be frequently accessed by the by the CPU needs to be kept in somewhat like a faster memory, so that it can be accessed quickly compared to that of main memory, which is quite slower. So, but however, the efficiency reduction mainly it depends upon several other factors also, whether like how the data is being introduced into the cache, and like based on what parameters like the new data is getting into the cache. So that will be deciding whether there will be a cache hit or miss. So if there is a cache miss, anyway, finally it has to be accessed by the main memory. So if whatever time that is there in checking the cache, that can be additional wastage if there is a cache miss. So there are several other factors also which will be coming into effect. Yes.
Okay. You know a diagram of memory hierarchy. Memory hierarchy diagram.
Yes.
Triangle.
Can you draw it? Okay. Yeah, this is almost correct. Yeah, you can also see. Yeah, this is correct.
So are we able to see
थोड़ा सा पीछे हाँ register then
register, cache, and then RAM, ROM, then secondary
हाँ
and hard disk at last.
okay okay this is almost correct. Something is missing I guess magnetic memory.
Okay.
Okay,
Yes.
you can cross check it.
Yes. Yes.
Okay. Now we can start with Verilog, basics of Verilog.
Okay.
Yes.
Okay. Tell me the difference between VSDL and Verilog. Verilog and VSDL difference.
Both are HDL languages which is used to describe the hardware. I mean,
Yeah.
what
You
it has
can
some
skip.
syntax. It has some syntax difference. That is what I'm. Okay, that's.
You sure you can continue?
Yes, sir. I don't know that much difference, but I know it's a Verilog and these are both are hardware description language.
Which is a strong type language, which is
I guess VHDL.
okay. Okay, fine. Just check it once. 2 3 difference.
Yes.
Tell me the difference between edge and wire.
Uh, in general, reg will be used as a left-hand side assignment in the procedural blocks, which can reg has the default value of unknown, whereas wire has a default value of high impedance state, and register is tends to store some data, whereas wire is continuously driven.
Hmm.
Yes.
Okay. You sure you want to add something?
Yes, sir. Normally, reg is something which we use when we want to store anything, and it can be overwritten depending on the code that we have written. And they somewhat differ from the normal registers that we talk about because they don't need any clock, and by default it will be storing an unknown value. Whereas a wire is generally comes under the net class, and it by default it will be storing a high impedance value and it needs to be continuously driven by the inputs in order to produce some output. Yes.
Okay. Oh, you know the difference between double equals to and triple equals to? What is this?
Yes.
Double equals to and
Yes.
triple equal to. Yeah.
In double equal, in triple equal, actually, both x and z will also be verified. Suppose if a triple equals b is like a case equality, which will check if suppose a is 10 xz, b should also be 10 xz. Only then it will be matching. Whereas in double equal, if suppose unknown can be treated as some don't care.
Okay. Yeah. You want to continue, Kishore?
Yes, sir. Double equal to is the like the equality operator, which will be comparing the whatever bits that are there. If they are equal, it will be returning a one. If they are not, it will be returning a zero. Whereas if we need to compare in presence of these unknown values or high impedance values, then we will be trying to use this case equality operator. It will be comparing the x and z values, and if they are exactly same in both the cases, irrespective of like x and z is present, also it will be returning a one if they are equal. Yes.
Okay. Fine. Okay. Verilog is case sensitive or not?
Yes, it
Verilog
is
Yes.
is
case
case
sensitive.
sensitive.
Case sensitive.
Okay. Mm, but VSJ is not right. The one is this difference also. But I think blocking and non-blocking. You can tell me the difference between blocking and non-blocking.
Uh, in uh, in general, we use blocking statement. Non-blocking statements are completely specific to this procedural blocks. And coming to blocking statements, if in the procedural block, it blocks the execution of the further steps And whereas in non-blocking assignment, right hand side expression will be evaluated first, and later all the right hand side expressions will be evaluated first, and later it will be assigned to the left hand side at a time, based on the begin and or forejoin that is being used.
Okay. Oh yeah, Kishore, you want to continue?
Yes, sir. Non-blocking statements uh, need not be, but normally they can be. They are preferred to be used with continuous assignment, whereas uh, blocking statements are preferred to be used with continuous assignments, whereas non-blocking statements are generally preferred with procedural assignments. Suppose if we take flip-flop or any sequential circuit, at a certain clock edge, there need multiple events need to be triggered at the same time. So in such a cases, like we can prefer a non-blocking assignment so that multiple events are occurring at the same event. So in such a cases where we need a sequential data transfer, we will be preferring. It is preferred to use non-blocking assignments over blocking assignments. Yes.
Okay, okay. Also, just explain this through the like some example in the interview, right? So that it will
Oh,
be
yes,
more
sir.
clear.
Yes.
Yeah. Okay, tell me about the regions. You know about the regions in Verilog?
Yes, yes.
Yeah, tell me about the
Uh,
regions.
in the first stage of region, I mean, all whole active statements will be get executed, where these blocking statements and the dollar display statements and uh, right hand side expression of this non-blocking assignments comes into picture. These will get evaluated first. Later in the second stage, hashtag zero, the statements with hashtag zero will get executed. Whereas in the third stage, the non-blocking assignment will get assigned to this left hand side value. In the fourth stage, this dollar monitor, dollar strobe, these kind of signals will get executed.
Okay, Kishore, you want to add something?
Yes, sir. Normally, these statements are like whenever multiple events need to be happen. So there is like a queue process. So first, they need to be executed in a certain way so that it can resolve the dependencies between them. So in such a case, there is some particular ordering. So that ordering will be preferred by the simulator in order to accordingly. Yes.
Okay, fine. Okay, tell me the difference between task and function. Task and function.
Yes. Functions does not will functions can only call another function, and it cannot contain any delay expression inside it. Whereas in task, it can either call function or it can also call task. Task can contain expressions with delay, and function must have at least one input argument, and function should not contain any in-out or output arguments, whereas in task it can contain both input and output or in-out arguments. And the function can return by default. Function is of return type of reg, and the function can return any value, but task cannot return any value. It can directly drive the output, but it cannot return any value. And tasks are in general used in test benches, whereas in functions are in generally used in designing.
Yeah, Kishore, you want to continue?
Yes, sir. Normally, functions can call another function, but they cannot call a task. And function always needs to return some value. By default, if nothing is specified, it will be returning some unknown value. So if it is specified, it will return some value, and it needs at least an input argument. And there is some constraint like you cannot use out arguments or in-out arguments within the function. Whereas in case of task can call a function as well as another task as well, and the task won't be returning any value. It will be directly passing the arguments that as some in-out as some output values. Whereas yes, sir, the tasks are mainly used in uh, test benches, whereas functions are used in the design.
Okay. Okay. Tell me about the sensitivity list. Tell me about sensitivity list.
sensitivity list, I mean, in general, for procedural assignments, the sensitivity list can be used either posage, negage, or level sensitive will be there.
Yes, sir.
So yeah,
Sensitivity. Okay. Sensitivity list will be deciding when the statements within this always block will be triggered. So
okay.
it can be any signal.
When they can change the state, right?
Oh,
Okay.
Yes.
Okay, tell me the difference between asynchronous and synchronous reset.
if in asynchronous reset, the procedural block will be, I mean, irrespective of the clock edge, the design is going to run its operation. I mean, if suppose reset comes, it will directly run the reset logic. Whereas in synchronous reset, even though reset triggers, it will wait until the clock edge comes, and later the based on the after clock edge only reset will perform its operation.
Okay. Or just write a diagram also, like make some example, right? You can
In
write the
Verilog,
code.
sir. Yeah.
Yeah, very good. Kishore, yeah, you continue.
Yes, sir. Reset is of like two types, as you have said, asynchronous reset and synchronous reset. In case of asynchronous reset, like as the name is suggesting, the reset signal is somewhat not synchronous with the clock. Like it doesn't obey the clock. Suppose if I take a active low reset, whenever the reset is active low, so it won't be checking at the active edge of the clock, the system will be reset. Whereas in case of synchronous reset, this is like one thing which is in synchronous with the clock, so that it will be obeying the clock. So if as I consider, suppose active low reset, this active low has to be at the active edge of the clock if I need to really reset the system. So yes,
Okay. और just write code also.
yes.
फर्स्ट वाला कौन सा है? फर्स्ट वाला किसका है?
First वाला asynchronous, sir.
ओके.
Second one
और
is
सेकंड वाला सिंक्रोनस का है.
synchronous.
ठीक है. करेक्ट है.
So I will see.
हम्म. नहीं
In the
नहीं
first,
दिखा.
so like in the first one, I wrote always at the rate of passage of clock. Within that, if negation of reset, Q equal to 1 bit binary 0. Whereas for asynchronous reset, within the sensitivity list only, I have included the reset.
Okay, fine.
Yes.
Tell me the difference between dollar monitor, dollar display, and dollar stop.
Dollar DOS displays positional specific. At Whenever it gets triggered, it will display whatever the values that the variable is containing. Whereas monitor, whenever any variable inside the dollar monitor is changing, it gets triggered and it will display the result immediately. Whereas dollar strobe is similar to dollar display, but dollar displays the value whichever it consists, the variable is having just before that. But dollar strobe waits until the that whole completion of that whole time. Suppose in 0 nanosecond, at last whatever the values will get assigned to those variables, those will be assigned in dollar strobe.
Okay. You can write the example also. One example of this. Kishore, just tell me.
Yes, sir. Dollar display is like suppose at the last instance, whatever the variable values are there, those will be displayed accordingly. Whereas a dollar monitor is suppose whenever any of the signal, whatever that is mentioned within the dollar monitor statement changes, so it will be displaying whatever signals that are there in the dollar monitor, it will be displaying. And suppose a dollar monitor works in such a way like if there are multiple dollar monitor statements, the whatever the dollar monitor statement that is there at the last, that will be active. And dollar display is somewhat similar to like printf, which creates a new line by default, uh, similar to somewhat like C. And dollar strobe is like suppose if there are multiple non-blocking assignments, and within that it will be trying to display the last non-blocking statement. dollar stroke.
Okay, okay. Ravi, you done? Okay.
Yes, 1 minute.
Okay, take care. What is the difference between transport and inertial delay? Kishore, inertial and
Transport,
transport delay. Transport and inertial
transport,
delay.
inertial delay. It is somewhat like depending upon the pulse width. In case of inertial delay, whatever delays that are lesser than the pulse width of the ground, those won't be reflected. Whereas in case of transport delay, there is nothing like this pulse width concept. Whatever delay that is there, that will be reflected accordingly.
Okay. Ravi, you want to correct
Uh,
transport and inertial delay?
Transport delay is nothing but a regular delay, whereas in inertial delay, based on the suppose if the delay pulse width is, I mean, suppose if the pulse width of the input is lesser than the delay width, then that particular signal will get discard. I mean that will not get detected. In suppose in the example of assign a equal to hashtag 5 a and b, in this if suppose a and b, the output of this a and b is having the pulse width less than 5 unit, then that will not get assigned to this variable y.
What is the cause of both? What is the cause of both?
So, sir, cause
Cause. What is the cause of inertial and transport delay?
I'm not sure, sir.
So,
And one more thing, what I know about regarding inertial delay is like inertial delay somewhat can be implemented using those intra-assignment delay in Verilog. Suppose
Mhm.
something if I want to assign that value at 0th instant, first it will be stored in some temporary register, and at the given delay instant, that temporary value will be finally assigned to the final variable. So that is how intra-assignment delay works, and that is equivalent to somewhat like inertial delay. And transport delay is like a normal delay.
Okay.
Yes.
So transport delay is basically through the register inductors, right? And inertial delay is caused by the change in output in the gate, right? Okay, you can cross check it also later, no problem. You talked about a intra and inter delay, right? So tell me the
Yes, sir.
difference between inter and inter delay.
In case of intra delay, suppose if I wrote A equal to hashtag some 5B. So whatever value of B that is there at 0 second, that will be stored in a temporary register. And at 5 nanoseconds, the temporary register value that is at B's value at 0th instant, that will be assigned to A at 5 nanoseconds. Whereas in case of a normal inter delay, we can specify it as hashtag 5 some A equal to 5. So there is no need of any temporary register. Whatever value of B that is there at 5 nanoseconds will be simply assigned to A. Yes, sir.
Okay. Yeah, Ravi showed me the diagram.
Here I displayed various outputs. I mean, if I place dollar strobe, what will be the output here? If I place dollar monitor, what will be?
This is correct. In the in the like interview, na, you have to show it like that so that you can just explain it nicely.
Yes.
You can take the same question, inter and inter delay. Tell me.
Intra-assignment delay is nothing but if suppose it, a equal to hashtag 5b, this is can be termed as intra-assignment delay, where here b will be start executing at 0 nanosecond itself, but it will assign the computed value at 5th nanosecond to this a variable. Whereas in inter-assignment delay, if suppose I am giving hashtag 5 a equal to b, so here after 5 nanoseconds, this execution of this a equal to b will start.
Mhm. Just in the interview, write the example also, right?
Yes,
Yeah.
sir.
Fine. So almost 1 hour is over today. So we can continue tomorrow. Like we can do it second round tomorrow, fine? That is okay?
Okay.
Or
Yes,
today is fine? Yeah.
Yes.
Okay then. Thank you
yes,
so much.
Thank you so
Ravi,
much.
just a little bit focus on the like few things, right? these are the common questions, right? ये
Yes.
पूछेंगे तो अच्छे से प्रिपरेशन करो. Like you are telling two difference between combination and sequential. At least 5 रटे हुए होने चाहिए ताकि आप बता दो, है ना, जाते ही, है ना. तो वो क्वेश्चन सिंपल वाले तो आपको ऐसे करना है कि आपको कुछ नहीं आता तो वो उसका कंपनसेट हो जाए, राइट. सिंपल वाले
Yes.
क्वेश्चन तो पूछे जाएंगे, तो
हाँ.
ऐसे करो कि अच्छे से, है ना. और जैसे कि मैंने बताया सेटअप टाइम होल्ड टाइम में डायग्राम बना दिया, तो डायग्राम पे थोड़ा थोड़ा फोकस करो क्योंकि वो कोरिलेट कर पाता है थोड़ा अच्छे से, है ना. तो डायग्राम से एग्जांपल से थोड़ा अच्छे से एक्सप्लेन करना है वो, है ना. ओके देन, फाइन. सो या, एनी क्वेश्चंस है?
Sir, like how do I need to improve in any things? Yes.
डू यू नीड?
Any
Do I
improvements
need
that
to
which
improve any
तो
things?
ये जो लाइट चल रही है पीछे तो उसमें फेस नहीं आ रहा, तो
Yes, sir.
वो लाइट क्लिंग का ऑफलाइन होगा तो कोई इशू नहीं है, ऑनलाइन होगा तो एक बार
Uh,
देख लेना, है ना.
yes.
हाँ, तो अपने हिसाब से उसमें देख
Is
लेना.
it,
हाँ
is
अभी
it
परफेक्ट है, ये बेटर है,
yes,
हाँ ये बेटर है.
yes. So,
बाकी या जस्ट एक्सप्लेन थ्रू द डायग्राम एंड ऑल, सो दैट इज आल्सो मेन थिंग, राइट. सो डायग्राम एंड ऑल पे फोकस करना है. एंड जो नहीं आता उनको बोल दो कि नहीं आता, लेकिन घुमाओ मत थोड़ा, वो दिक्कत कर देता है कभी कभी, है ना. जो पता है वो बता दो कि इतना ये पता है, ये नहीं पता एग्जैक्ट, तो वो सही रहता है ना. So then we will take the next round tomorrow or day after tomorrow. Fine. Okay, fine.
okay.
Okay, good night.
okay, sir. Thank you.
Thank you, sir.